Hey, in our last video, we learned how to do pseudocode, which is just basically a plain speaking way that gives us an idea of how we're going to solve a problem in programming or coding. It's pretty useful if you're going to program robots or computers or anything like that. So look, let's begin by, we're going to open up our pseudocode from our previous assignment. If you closed it, if not, you got it open, but you go here, and then remember you did it down here. So you should be able to click this blue link and it'll open up this. And hopefully you got all that done in the last video because you need this for this assignment. What you're going to do is you're going to leave this on one of your tabs and then you're going to open a new tab here. You can close this other one or keep it open, doesn't matter. And you're going to type in spike.legoeducation.com. I'll put a link to that in this assignment too, so if you just want to click the link, that's fine. Now for this, of course, you're going to need a programming cable like a USB cord that's plugged into your computer. And you're going to need your robot with driving base number 1 assembled. This one's Anthony's. Thank you, Anthony, for letting me use that. It's in my 5th period class. So we're going to go to Spike Prime. And we're going to open project. Now remember, the last one was pseudocode. Before that, we calibrated a turn. Look, if you haven't calibrated your turn yet, you need to go back into the previous week's assignment and get that done before you do this. I have done it, so I'm going to go to Open Project, and I'm going to go to Right Turn, and I'm going to cancel. I don't need to save the changes. Here we go. Now, on this one, in the video before, the idea was you were supposed to figure this out too, right? So I'm going to type in, this is actually 0.5, seemed to work actually really well. But the first thing I'm going to do, which is kind of weird, is move that to the side, and we're going to save that for later. Okay, so it's just right down here, and we have to make sure, this is really important for this assignment, that you have the motor set up, that your wires are plugged into C and D, if that's where you plugged in your wires, I hope it is, and that you have your motor rotation set up to 17.5 centimeters. That's very important because today we're going to be using a ruler to measure how far the robot needs to go every time it moves forward. And we're going to set our movement speed to 50%. The reason is, if you go 100%, your wheels might slip and spin on the floor. Different parts of the floor, depending on where you're at, it's going to be a little bit different, or the tables or whatever, wherever you are. So we want to make sure it's going slow enough so it doesn't peel out and lose traction, which is inaccurate. It's kind of cool, but it's kind of inaccurate, right? Okay, so let's get started. We're going to look at our pseudocode, and it says to move forward. But before we do that, we're going to have when the left button is pressed, you could use the right button or whatever. I'm just going to use the left button. And we want to make a second delay so that when we press the button with our finger, we get our finger time to get out of the way, and then the robot moves. Because if you press it and it instantly moves, your finger might slow it down and throw off the accuracy or make it turn when you don't want it to. So the first thing we're going to do is go down to Control. You can click this link, go down to Control, and you're going to drag out, wait 1 second and put it on the stack, okay? And then we need to figure out, the next thing in our pseudocode is to move forward, okay? We haven't figured out what that really means yet. How far do we need to move forward? Let's find that out right now. All right, I'm back and I have a ruler. This ruler just happens to be in inches, that's fine. Our Lego software can use centimeters or inches, that's fine. So let's go down here and you can check it out. The first thing I want to teach you is every time you put the robot down, you need to put it down right in the middle of here and in the middle this way. And do it consistently the same exact way every time. Also, you got to make sure it's not rotated in any direction. It's facing straight forward towards, like parallel in the same direction as these walls. Okay, so what I'm going to do is measure how far is it if the robot has to go from the middle of this square to the middle of this square. So I can put my ruler down, slide it down here, and so it'd be about right here to about right here. Looks like it's about 17 inches. Let's double check that. If we measure from this piece to this piece, corresponding part, this end to this end, yep, about 17 inches. Okay, so let's go back over here and let's start programming this robot. So here we go. It says we've got our wait 1 second. Okay, you can even throw that in there. But we're going to wait 1 second to get our finger out of the way when we press the button. And here's what you're going to do. You're going to go back to movement. And here's the one for straight. If you want to turn, it's different, but straight, you can use this one. And we're going to slap it on there. We're going to move straight for 17, and this is really important. You have to make sure you change it to inches, not centimeters or anything else. Because we just measured it in inches. You could measure with centimeters, but we didn't. If you go 17 centimeters, it's going to go 2.54 times less than it should. Because that's the ratio of inches to centimeters to inches. Okay, so let's give this a try. Remember, we're going to do one thing at a time. Now, since this is a kind of a refresher, we're going to make sure that your robot is turned on. And I'm not going to show you how to program it and connect it every time, but the first time I will. I've got it plugged in. You can hear my computer kind of beeped a little bit. We're going to press the connect button. I've already updated it. If you haven't, you're going to have to do that. Connect with USB cable and open. There it is. Click this and then press connect. Okay, and we're not going to put the right turn on yet. That's next, but we're just going to do one step at a time. So we're going to move forward 17 inches after I wait 1 second. So let's press play to download the code. Okay, it's ready to go. I'm going to disconnect our robot, and you're going to see me put it on the ground, and let's see if 17 inches going forward works okay. Okay, again, it's right up, put the axles right in the middle of here, and line up this right in the middle of this one. So see, if you thought of this as a square, this is lined up right in the middle, and it's facing parallel with this, not turned to either side. So press the left button, waits a second, and then it goes. Hey, that looks pretty good. All right, so let's go back and let's going to add on a right turn and see how that works. So again, kind of annoying that you have to do this every time and answer all those little questions, but I'm going to plug in my USB with the robot still turned on. I'm going to press connect. Yep, connect with USB cable, open. Click this and this. I wish you didn't have to do that every time, but when you use the web browser, you kind of do. Okay, so we have a right turn that we calibrated from our previous assignment. And for me, it was right 100. Don't make sure that's all right 100, because then you're going to do a sharp turn in place and you won't hit the walls. If you do anything else, your robot's going to make a slow arcing turn and probably run into some things. It's possible to do it with that, but I don't want you to. I want you to use right 100 or left 100 later when we make a left turn. Okay, so we've got that connected. You can tell my robot's connected by these sensor readings that are up here. If it's not connected, you won't see those things. Or if you collapsed them, you won't see them. So now I have it ready to go, and I'm going to press play. Let's go ahead and take that back, and let's see how it works this time. If it works correctly, we should be going forward and then making a right turn. Again, I got to pay attention that my axles, that's where the wheel spins around, are lined up halfway in the middle, perfect, and it's not tilted. Okay, cool. That worked great. Now, I'm not going to solve the rest of the maze for you, but I do want to show you how to change to a left turn instead of a right turn. So what I'm going to do now is I'm just going to show you this part and show you how to use a left turn instead of a right turn. So this is a left turn. And then I'll let you piece all the stuff together using your pseudocode. So if we think about it right now, we've already got this done, and we've already got this part done. I'm going to skip forward, and I'm just going to show this part, which is move forward and left 90. Later, you'll have to go back and fix all these things, but I just wanted to show you that. So to change it like this, to change this one, so let's duplicate this so we don't lose it. I'll keep my right turn for later. And let's change this one. And what you do is you click right 100, and you click it, and you move it all the way over to left negative 100. In Lego programming, right would be positive 100, left would be negative 100. Okay, so left turns are negative, right turns are positive. Okay, and it's going to be for 0.5 rotations because that's what we've calibrated in the past. So let's plug in our robot and go through that annoying process that Lego makes us do every time. 2, 3, 4, 5, 6 clicks of the button. It's pretty annoying, I get it, but that's the way we're going to have to do it. And press play. And let's see if I just got that left turn correct. It's pretty easy to change, right? And again, we're using our old code and modifying it. Why work hard and you redo everything? So I'm going to put that about right in the middle, facing this way, and it should do a left turn. Waits 1 second. forward with a left turn. Yep, so that works. So what do you still have to do? So let's go back and fix our code, and we'll save the left turn for later. And so what would I do after this? I've got the move forward and right done. I need to do another move forward and right. Again, do you think I want you to work super hard on this? No, I want you to work in the most efficient way possible when you're programming computers or robots. So you should go up here, and if you grab right up here, right click and duplicate this, you should get another chunk like this. If you right click and duplicate that, you should have another one, and you can easily change it to a left turn or a right turn when you need to. Remember this though, when you get to the last one, you don't want to have a turn at the end because it just moves into the last spot and you don't need to turn, okay? You just go to end program. And of course, when you're done with everything, I'm not yet, but when you're done with everything, go down to control and you can stop all. So if you just put this out, stop all, it ends your program completely, okay? All right, everybody, good luck. Now, what do you need to do? You need to do two things to get graded for this. You need to show me the code on your screen of your computer, not anybody else's, on your computer, and you need to show me that your robot actually works in the maze. So when you call me and say, hey, I'm done, I'm going to look at your screen first, and then we're going to grade the code and see how it works. And if it works, hey, good job, you won. You got this one done. Hey, everybody, good luck. And remember, if you need any help, just hit me up. I'll be glad to help you.